to experience something glorious. Unacademy combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other, where you put your knowledge to test
and battle it out with the best.
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Good evening friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Malesham Devasane, I am working as an educator on Unacademy. On this channel, I am taking the classes for Discrete Mathematics, Theory of Computation, Compiler and also C Programming, where today is the first session for Graph Theory in the Sankalp batch. And the graph theory we are going to see for 3 days. Then we will see 1 day for combinatorics. As you know that it is a huge topic. It's very difficult to cover in 1 day, but important concepts that are required we will be seeing on 31st Jan. Okay, so today morning 8:45 a.m. it should have been happened, but because of some health issues I was not able to take. And let me start now the graph theory. Good afternoon, Umesh, Sneha. Good afternoon, Jyoti Singh. Good afternoon, Priya. Good afternoon, Lakshya. Yeah, good afternoon. Yeah, Ashish. Good afternoon. Lakshya already taken TOC PYQ and I will take soon. No, Lakshya, I have taken so many, but maybe on special classes I have taken. Looks. Yes, Manoj. Yeah, you will be knowing tomorrow everything about the practice sessions. So don't worry about practicing PYQ. You will be having a lot. Fine. In case if you want to follow my profile, please visit unacademy.com/devagatecse. You will have a lot of sessions on my profile. You can find all of them are free, and this is where you can access all my classes freely. In case if you want to take the subscription, you can use the DEVALIVE as referral code to get 10% discount, also to get the guidance for preparing GATE. Yeah, this is the first batch started by RBR, where it started on 18th Jan, and you may take the subscription by using the referral code DEVALIVE. And we are looking at now discrete mathematics, that is every day. It's actually now timing is changed, 8:45 a.m. every day rather than 9 a.m. and this is gonna end on 31st Jan. Probably remaining are going on time except mine. Yeah, in case if you are not aware of Unacademy learning app, you can go to Play Store, you can search for Unacademy learning app and install, and also enjoy watching on mobile. Yeah, we have two kinds of subscriptions on Unacademy, Plus and Iconic. If you are aware of these two subscriptions, Plus you have various plans again, like 1 month, 3 months, 6 months, 1 year, 1.5 years, 2 years. And what is the advantage of Plus? Any course that we have launched inside the Plus, it's absolutely free, but only the thing is how many months you take the subscription, how many years. So here you can join any batch or every batch. You can listen hundreds of times same course if you want it. But E Plus advantage is you will be having the unlimited access to the content and live interactive classes and weekly test doubt solving sessions. And when you look at Iconic, all the benefits of Plus, but Iconic has the one thing, that is dedicated coach to guide you all the time. And you also have one-to-one interaction with an educator. And you have separate study material and separate study plan and many other benefits on Iconic. In case if you want to know about the Plus, the different plans, among them we always recommend to go for 1 and 2 years. But in case if you have less time, you can, if you are able to complete all the courses in less time, you can also go for 6 months, 3 months, 1 year, 1 month. Okay, if you are going for 2 years, that is 39,600 after applying referral code DEVALIVE. Similarly, Iconic is having 66,600 for 2 years. So you may choose as per your comfortness. Guys, I'm sorry. And there is a placement batch which is started on 26th Jan. If you are preparing for placements to crack the coding interviews, and this code chef certification and guidance is gonna help you, and which is looks like subscription cost is 90 rupees per day. If you are going to take the subscription, you will have teaching assistants to support your doubts. And if you want to take the subscription along with a GATE competitive program on Plus, you can go for 1 year 51,233 rupees. You may use my referral code, or any referral code on Unacademy is applicable to get 10% discount. Yeah, so you have so many benefits of joining this batch. You have top educators to guide you all the time, and these are the educators who are going to guide you in competitive programming. Yeah, let me start the session now without wasting the time. Yeah, in previous sessions we have seen set theory, where sets, relations, functions, and also group theory, lattice theory. We have seen the all important points, and a propositional predicate logic is the next thing, where we are going to have a practice session soon on these topics, whatever I have completed. Yeah, now today in this session we have planned basics of graph theory and types of graphs and connectivity. These are the 3 things that I am planning to cover up. Yeah, good evening Lojit. Fine. There are various graphs, but we are always looking at applications in simple graph. Okay. Let's begin. Yeah, hello Deepak. Let's begin this simple graph. What is simple graph? What is simple graph? The definition is like this. It can be directed or undirected. It can be connected or disconnected. Then what is directed, undirected? If it is directed, you will have a graph with edges like they have a relation from one vertex to other vertex. There is an edge which is directed edge. Undirected, you will have an edge between two vertices without any direction. And connected, disconnected, if all vertices are connected by some means, like directed, undirected, you have different definitions for connected and disconnected. So I'll be helping them soon. And no self loops and no parallel edges. Yeah, good evening, Pia. Clear? What is a simple graph? It might be directed or undirected. It might be connected or disconnected, and it should not have any self loop, and it should not contain any parallel edges. This is the simple graph definition. But anyhow, I'm going to help you all the definitions soon. Right? All the definitions I'm going to help you soon. But let's start with a few things which are important to learn any topic in this graph theory. Let's start with a degree of a vertex. Before that, what is a graph? Anybody is not aware of at least what is a graph? Let me help you. Graph we represent like, let's say G. It is a collection of vertices and edges. And we represent a set of vertices. And E represents set of edges. If you are aware of a graph, the vertices also called as points, also called as nodes, right? You can use any name for the vertex. Vertex, point, node, all are same in graphs. And edges, you can also use lines. Edges, lines, which are same in graph. Okay, if you want to look at the example, if you look at this graph, this is the graph G. So you can represent as V nothing but 1, 2, 3, 4, and edges are many. I can represent directed, undirected in two ways. You may use either parentheses or brackets, is your choice, but I'm using parentheses, but still assume this is undirected. Don't assume directed. It looks like 1 to 2. In directed, we use this kind of pair. 1, 2 and 2, 3 and 2, 4 and 3, 4. Assume they are undirected pairs. Yeah, hi Pranay. I hope everybody understood what is a graph, which is not difficult for many people, which is very easy to remember and understand. Okay, let's move on. Concepts that you require to understand in this graph theory. Okay, first, degree of a vertex. Assume graph has vertices and edges, and I'll be helping you connected, disconnected, many things are there just after these concepts. Degree of a vertex. What is the degree of a vertex? If you are looking for a degree of a vertex, directed graphs, undirected graphs, we apply this concept a different way. If it is undirected graph, we just have a degree definition. If it is directed graph, we use in degree, out degree. So I'm going to help you later on in degree, out degree. Hello Shubham. And what is the degree of a vertex? If you are looking at the graph first time, let's say this is your graph. And what is the degree of a vertex? If I say degree of A, how many edges incident on A? Just one. And what is degree of B? How many edges incident on? Number of edges incident on a vertex. Here 3 edges are incident. And what is the degree of C? Is a 2. And degree of D, which is 2. And if you look at any edge, every edge is counted twice. Yes or no? If you look at E1, is counted in A as well as B as a degree. So remember one point, when you are doing the sum of the degree sequence, then you will get the twice edges that I am going to talk about. Edges counted twice in degrees. If you look at, yeah, thank you Abhishti. Yeah, no need to say. If you are enjoying the sessions, it is your choice whom to dedicate, but we always here to guide you. Wherever we work, we definitely guide you. Yeah, you come to special, you come to YouTube, you come to plus, you see the same effort, that what we give the guidance to you will be same. If you look at in degree, out degree, look at here in degree. Sorry. What is in degree of A? Now you say that in degree, number of edges coming towards A. There is only one edge which comes towards A, incoming edges to the A, that is 1. And similarly in degree, every vertex you will have something at least 0 if you don't have any. Now only one edge is coming towards B, that is 1. And in degree of C, how many edges are coming towards C? There are 2 edges now. And in degree of D is also 1. Now if you want to calculate out degree, now number of edges coming from that vertex. In degree of A, only one edge is going outward from A, that is 1. You can easily calculate this. Only one edge is coming from B to the outside. Out degree of C, 0, because no edge going from C. In degree of D, it is a 2. Sorry, out degree of D is 2. Because there are 2 edges which are going from D. One goes to A, other goes to C, other connected to. Yeah. Now look at this in degree and out degree. There is a connection between these degrees. What is that? The sum of the degrees of vertices. Now let me talk about this first one. What is the sum of degrees? If you do sum of degrees in this graph from all the vertices, will you get twice the edges? Look at that. Sum of the degrees in this graph, let's say we write like this, sigma, if there are 4 vertices or n vertices, I is equal 1 to n, vi, that's a degree of vi. Degree of vi is equal twice the edges, 2 into e. E represents the set of edges size of e. And why twice the edges? Because you know that every edge is counted twice. Then when you sum the degrees, then definitely you should get the twice the edges. Like E1 is counted twice, E2 counted twice, so there are 4 edges. You should get the sum is 8. Did you get the 8? 1 plus 3 plus 2 plus 2 is actually 2 into 4. Right? Everyone? Yeah, there are so many questions in ISRO, TF or GATE from this sum of the degrees. Yeah, any kind of graph. You take any kind of graph. is a simple, connected, disconnected, multi-graph, any kind of graph, this concept applicable. But you should know how to calculate the degree. Some people are not aware. Suppose you have this one. If you have a self loop, what is the degree now? What is the degree of this vertex? If I ask degree of A, which is equal to, if you have, let's say, self loop like this, here in degree, out degree. If this is A, then here in degree of A is 1 and out degree also 1. And you should know exactly how to use for other graphs too. Then only the sum of the degrees will guarantee is equal twice the edges. Yes, Shiva, right. For all kind of graphs, this theorem is applicable. Yes, every edge contributed 2 degrees. That's correct. North, south. Everyone, so I hope here also is applicable. Here sum of the degrees we say, but here in degree sum plus out degree sum. Here sum of in degrees. Plus sum of out degrees is equal to twice the edges. Why? Because every edge is participates in both in degree and out degree. In degree and out degree. Remember that point? Every edge is covered in degree and out degree. Yeah. I think here there is any wrong here. Look at guys, sometimes I do mistakes. In degree of A is 1. In degree of B is 1. That's right. In degree of C is 2, right? In degree of D is 1, right? Out degree of A. Out degree of A is 1. Out degree of B is actually 2. So I have just written as 1. Okay, there was a small mistake that I did. In degree, out degree of B was 2. Okay. Now when you look at the sum, you will get sum of in degrees will be, what is it, 5. In even out degrees 5. You can see that, which will be 5 plus 5 into 2 into 5, which will match. Yeah. Everyone, so this is easy topic. Yeah, don't worry much about it. But we have so many interesting points. Let's look at. This was the gate question. A recent gate question, which was, which of the following statement is true for undirected graphs? Number of odd degree vertices. Here undirected, why did he use? Because he's not saying in degree, out degree. So when you don't want to say in degree, out degree, just say undirected. The number of odd degree vertices is even. Sum of degrees of all vertices is even. So which of them is right? Both are right or only one is right? Let's see who will answer it. You know, sum of the degrees is even. 2 into number of edges, which is nothing but even. Sum of the degrees always even, no doubt about it. So this looks like Q is fine. What about P? If you have odd degree vertices, how many odd degree vertices? How many odd degree vertices in any graph you take? How many odd degree vertices? Do you have even or odd? Good afternoon, Nikhil. Number of odd degree vertices. If we look at the previous one, here odd degree vertices. Of course, in degree, out degree, you have to say separately. Now look at this one. Here, there's A and B. There are 2 odd degree vertices. Is it possible odd number of odd degree vertices? Always even, always even, always even, always even. Yeah, because sum has to be even. So number of odd degree vertices must be even. So P also right. But if I ask, there is another point, or number of even degree vertices. How many even degree vertices? Number of even degree vertices can be even or odd. The number of even degree vertices can be even or odd. Even R is also right. If I say can be even or odd. Right. In future they might ask about this point too. Yes. Now let's move to the degree sequence. Now, any graph that you take, you will have a degree sequence. Everybody agree? Okay, I'm talking about undirected graph. Let's say degree sequence. What can you talk about? Yeah, Rishabh, use induction principle. Rishabh, if you are gonna prove everything here, graph theory will not complete within 6 hours. It will take even 30 hours, Rishabh. Right. Degree sequence. What is degree sequence? You know, if I have a graph, let's say, I'm saying, let's say 2, 2, let's say 1. Is there any graph with this degree sequence? Sometimes you can easily say impossible to draw a graph. Impossible to draw a graph because how many odd degree vertices? How many odd degree vertices? Only one. One is odd. That's impossible to have odd number of odd degree vertices. You can say there is no graph with the degree sequence. So what are the points you can add to understand this degree sequence of a graph? Right? The first point, you know, sum of the degrees must be even. नहीं आशीष, अब नहीं, 3 दिन का 2 घंटा 2 घंटा 2 घंटा 6 घंटे होता ना आशीष. Graph theory will be covered in 3 sessions. And second point, even number of odd degree vertices. Just now we know that. Yeah guys, please like the session. If you have not yet done, please like the session guys. Even number of odd degree vertices. Apart from this, what else you can talk about? What else you can talk about when you have the degree sequence? Suppose guys, I have let's say 4 vertices. What could be the maximum degree of your vertex? Look at this. I can connect to this. I can connect to this. Assume simple graph. I'm applying simple graph. Whether it's connected or disconnected doesn't matter. What could be the maximum degree if you have a 4 vertices? For n vertices, minimum can be 0. Maximum degree must be n minus 1. अगर कोई दिया ना n plus 1, n plus 2, impossible to draw a graph. Because a vertex can be connected to all the vertices at most, that makes n minus 1 degree. And apart from this point, look at any graph, any simple graph in the world. There is one theorem, that is at least 2 vertices must have the same degree. At least 2 vertices must have same degree. Otherwise not possible to draw a graph. Look at this. This is a 3 degree, 1 degree, 1 degree, 1 degree. Here 1 degree is there for the 3 vertices. Even you connect this degree become 2. Look at that. 2 degrees there for 2 vertices. At least 1 degree among all the degrees should appear for at least 2 vertices. Everyone, even if everybody has a proof here, but only proving is difficult in undergraduate level. Even all proofs, all theorems have the proofs here. Remember, everybody is here a theorem. You can say that. Sum of the degrees must be even. Any simple graph you take, even number of odd degree vertices, must be even. That is second point. For n vertices, the maximum degree in the graph should be n minus 1. At least 2 vertices in the graph should have the same degree. So by using these points, I can easily eliminate the options in the exam sometime. So why do you need these points? remember them so that you can eliminate the option. This will help you to eliminate the option. These points will help you to eliminate the options in the exam. But will not help you to understand whether the graph exists or not. So this degree sequence of any graph, they satisfy these 4 points. But if you satisfy these 4 points, no guarantee graph exists. Remember my words. Remember the words. If graph satisfies all these 4 sentences, no guarantee graph exists. But if the graph exists, definitely these 4 points satisfies. Everybody understood why we use for eliminating the options? There is no guarantee still graph exists or not. So this degree sequence will help us whether the graph exists or not. Look at now, we have 4 degree sequences. We have 4 degree sequences. That 4 points may eliminate the options. Sometimes you can look at that, how many odd degree vertices are some of the degree sequence, right? You can use that 4 points. Okay, can you eliminate by using that 4 points? First, let's try elimination, then we will start a theorem to draw a graph. Okay, look at 4 points. Some must be even very complicated. Don't do that. So among these two, use just one. Even number of odd degrees and these two are actually same. You don't need to find out both. If number of odd degrees even, then some has to be even. So no need to check both. That's another point. Okay, just look at how many odd degrees. 1, 2, 3, 4. Fine. And 1, 2. Fine. 1, 2. Fine. 1, 2, 3, 4. Looks like all sum is even for all. So that is failed. Now look at how many vertices. 1, 2, 3, 4, 5, 8. 8 vertices you have. Yes or no? Everywhere you have 8 vertices. So option 4 you can eliminate blindly. Why? When you have 8 vertices, degree should be maximum 7. Is that clear? Degree should be maximum 7. You can eliminate easily the 4th one. So you don't need to verify the 4th one. You can eliminate. And look at another one. Is every sequence, do you have at least 2 degrees are same? Yes, here 4 degrees twice appeared. Yeah, 6 appeared more than once. That's fine. Yeah, in all of them. So now only you need to check. Yes, Havel-Hakimi theorem you can apply. Exactly. Everybody, now start the theorem. What is the theorem says? You need to start verifying in some sorted order. Always keep some sorted order. So let me help you first. One sequence. How do you apply that Havel-Hakimi theorem? Of course, name not required to remember, but people remember it. That's fine. This is your degree sequence. First, what you do is, first make sorted order. It's already sorted order, but that is in decreasing order, non-increasing. What is the funda here is, the highest degree we will satisfy first. Matlab, if this is a V1 degree, if this is a V1 degree, then V1 vertex we will connect to all other. That means to satisfy this one, we connect to all the remaining vertices so that its degree will become 7 or not. Of course, I am not going to draw a graph, but indirectly you are drawing it. So this vertex degree is a 7. If you assume that is a V1, you are going to connect to everyone like this, so that the degree will become 7. How many edges you connect to them? 7 edges. 7 edges. So to satisfy this 7, what I do here is, I do -1 everywhere. If it is 6, I will do -1 6 times in a sequence. So in the second step, before second step, what do you get? The 7 becomes 0 because that vertex is connected to remaining all to satisfy the 7 degree. And 6, among them, 1 edge is connected, so this becomes 5. And 5 is already 1 edge is connected by that 7, so it will become 4, then 3, then 3, then 2, then 1 and 0. Those vertices, they have the degree 0, they already satisfied their degree. So in the second step, just work on the remaining. And but make it sorted order, in decreasing order. Everybody, so what I did is, First, keep in decreasing order, and highest degree we are going to connect to remaining vertices to satisfy the degree of the highest degree, degree of the vertex which has highest degree. And second, now whatever this vertex doesn't matter, we are going to connect to 5 vertices. If you have more than 5, then we will only connect to 5 so that its degree will be satisfied. Okay, but we are not drawing the graph, we are only verifying exist or not. Okay, 5 connected to them. Everybody understood? So what I am going to do? I'm going to get 0, and here I have connected. So minus 1, minus 1, minus 1, minus 1. So 3, 2, 2, 1, 0. Now in the third step, no need to consider 0 degree vertices because they satisfied. Remaining vertices, make them sorted order. Now third one. That third one I am taking again. Now this one we are connecting to 3 vertices because to satisfy 3 degree we need to do 3 edges connection. You get a 0, 1, 1, 0. And now in the fourth step, just take 1, 1. You know, it's a trivial. You can always connect these 2 vertices. Then graph, you can say that at this point is a base case, you can take 1, 1. Now for this 1, 1 is possible to draw a graph. So indirectly given degree sequence also. Yes, graphic you can say. Graphic means we can draw a graph. So the first point. Yeah. Everybody? Yeah, Aditya, what are you saying? पढ़ने के लिए आया, मज़ा के लिए आया यार. Okay, now can you do quickly? Just to explain first. Yes, one is possible to draw a graph. Now I'm going to verify for the remaining. Look at quickly. How do I do that? Second one, 6. First sort it if they are not given in sorted order. Right. So you are going to connect. Cancel it. Put a minus 1. Very short. But only 6 times. Only 6 times. Only 6 times. Don't do 7 times. In the second, what do you get? 5, 5, 5, 2, 2, 1 you are getting. First take a 2, then take a 1. So I'm just sorted it. 2 become 1. That one I sent last. Yeah. Then third step, what you do is 5 I'm going to cancel, but minus 1 I do 5 times. Then what happens? 4, 4 and 1, 1, 1. Everybody is 1 remaining, so it's fine. Now this 4 I am going to cancel and I am going to do minus 1 4 times. 4 times only. And anyhow, the 4 become 3 and remaining are 0. The last one is 1. 3, 1 is impossible to draw a graph. Do you have any graph in the world with 3, 1? 2 vertices you have. 2 vertices you have. Yes. If the last step you show that 0, 0. Last step you show 0, 0. That means the given degree sequence have some graph. Yes, Shiva. Now look at this 3, 1. Can you draw a graph? No. Graph exists. So indirectly the given degree sequence has no graph. Clear this point? Yes. Every step, indirectly you can understand easily what I am trying to say. See, you have 4, 3, 2, 2, 1. Let's say 1. This is my degree sequence. 0 also might exist. It means you have indirectly 7 vertices. 7 satisfied. No problem with the 7. Now V1 we are going to connect to V2, V3, V4. Now look at how much need to satisfy for V2. 2 degree. So 3 we made 2 minus 1. 2 how much required to satisfy? We made minus 1 minus 1. So remaining degree will become 2, 1, 1. Yes or no? And here V5 and 4 degree, right? Here also minus 1.
Then V5 satisfied, V7 satisfied, V1 satisfied. Now remaining you should work on V2, V3, V4, V6. But V2 degree remaining is 1. V4 is 1, V5 is 1, V6 is 1, V5 is already satisfied. Now V2 we are trying to connect to V3, V4. That means V2 we connect to V3, V4. Now the V2 completely satisfied, V2 completely satisfied, V3 also satisfied, V4 also satisfied, only V5, V6 left, and it's not possible to draw a graph. Now remaining all vertices satisfied their degree. Now look at it, 4, 3, 2, degree satisfied or not, check that. First vertex degree is 4, second 3, third 2, fourth 2, and fifth 1, but sixth failing. So impossible to draw a graph with this degree sequence. Everybody, why we are taking the maximum degree to satisfy? Just it's a technique to help you. It will help you to understand, okay, whether the graph exists or not. But we are not showing the graph to anybody because there might be many graphs with the same degree sequence. Yes or no? There might be many graphs. Okay, last one. That is third one. 7, 6, 6, 4, 4, 3, 2, 2. Keep in decreasing order all the time, non-increasing order. So first step, 7. I'm going to satisfy so that I do -1 7 times only. Don't do more than that. Okay, in the second step, before that you can write all of them and take the sorted order. I'm just writing 5, 5, 3, 3, 2, 1, 1. So it's already in sorted order, so you can take that. 5, 5, 3, 3, 2, 1, 1. Now satisfy the highest degree and look at -1, what is going to happen 5 times only. Don't do 6 times now. There are 6 vertices. Even though 6, we don't do 6 minus 1s. And what do you get? 4, 2, 2, 1, 0, 1. So no need to take the 0. This is already satisfied. So 4, 2, 2, 1, 1. And 4. Delete, -1, apply 4 times, and in the fourth step you got 1, 1. That's all. 1, 1 is graph possible. 1 you cancel, do the -1, you got a 0. So finally you got a 0. That means every degree we made it possible because graph exists. Yes, Shiva. If you remove V6, it is possible. Yes, otherwise add V8, keep V8 with 1 degree, you can connect it. Okay. Yeah, so 3 also possible, 3 also 1 and 3, 1 and 3, option A is the right. And which was the recent year, I think 2018 around, this was asked. Even there are many questions, look at first. Now again the same question, not graphic. They are asking now which one of the following is not graphic. Don't check for the graphic, remember. Many things are graphic, just check the not graphic. Look at these 2 can be connected, these 2 can be connected, these 2 can be connected. This is possible. And 2, now 1 was very easy to verify, but 2 means just connect this one with this 2. Then you need to do step by step so that it will become so easy. 1 was very easy to verify. Of course this was a disconnected graph, but they didn't ask you connected or disconnected. You are going to verify graph exists or not. Okay. Okay, option B I am verifying. So I'm connecting this vertex to other 2 vertices. Okay, and then you got 1, 1, 2, 2, 2, but sort it first. Sort it. If you sort it, 2, 2, 2, 1, 1, and these 2 cancel it and connect to the next 2 vertices. Then third will become 1, 1, yes, it is possible. You can stop here, you can check that. Yes, these 2 can be connected, these 2 can be connected. Yes, this is also possible. And next one you can check. 3 you can connect to next 3. so that you get 2, 2, and remaining all are 0, and 2, 2 is not possible to draw. You can see that. Next step you get 2, 2. That option C is very easy to verify. Option C is very easy to verify. 3 cancel it, then -1 you get it. 2, 2, remaining are 0. So next step is 2, 2 is not possible. It's not graphic. So indirectly given 1 is not possible. So you got the answer, you can tick it. But if in case if it is MSQ, check last one. So 3. The option D I am checking now. 3, 2, 1, 1, 1, 0. And cancel it, -1 3 times. So you get 1, remaining are 0, only last one is left. Right? So in the second step, what do you get? 1, 1. You can see that. Yes, possible. Yeah, answer C. This is very easy, and many gate questions were there on degree sequence. So don't leave this question if it comes. Very easy to secure the marks. Yeah. Now, I hope you understood the degree sequence. Yeah. But if they are asking connected or disconnected, connected graph exists or not, you should work very hard. Look at option A, connected graph not possible. If you look at option A, to satisfy the 1 degree for 6 vertices, you have to make like this only. Everybody, here option A, connected graph not exist. And option B, you need to try. You need to try to make connected, because if they ask connected graph exists or not, they might ask connected graph exists or not, disconnected graph exists or not. You need to try all of them separately. And this theorem will not tell you is the graph connected or not. It will tell you graph exists or not. That's all. Everybody? So in case if they ask graph exists, connected graph exists, then you should work for connection. Okay. Now let's look at the types of graphs. I just help you to understand the basics, but in the basics there are so many things to understand. And I was talking about simple graphs. But you know, non-simple graphs also exist, like pseudographs, where you can have self-loops, parallel edges. Multigraph will have parallel edges. Everybody knows pseudograph may contain self-loops and parallel edges. What do you mean by parallel edges? Suppose you have A vertex, B vertex. Self-loop means this one, if it is undirected. If it is directed, you will put arrow. Parallel edges, for directed, you draw like this. For undirected, you may draw like this. Right? Parallel edges for undirected, parallel edges for directed. You know, there are two graphs always we have, directed and undirected. Directed graphs will have, we always represent with an arrow for every line. Undirected we represent without an arrow, just simple line. This is directed edge. Every edge is directed and every edge is undirected. So graphs are two types. Yeah, Nishu, good morning. And connected and disconnected. And we are going to spend much time on connected and disconnected today in the connectivity. Everybody? And don't worry, connected, disconnected now. Connected directed graphs different, connected undirected graphs different. So we are going to spend much time. But a very simple definition I will give you. Connected. Suppose I have A, B, and C, and I have a D, E. See, I have 5 vertices. Are they connected? No. This graph is called as disconnected graph, where D and E are not connected to ABC side. Disconnected graph. Everyone? That means some vertices are not having a path with some other vertices, basically. In undirected graph, very easy. At least 2 vertices, they don't have a path in between. That means graph is disconnected. Everyone? But saying for directed, it's not at all easy. For directed graph, this connected definition is not easy. Today I will help you. There are many definitions like strongly connected, weakly connected, unilaterally connected. So I just want you to remember connected, disconnected graphs both are exist in the world. Okay, I will define clearly. And cyclic and acyclic. What do you mean by cyclic? What do you mean by cyclic? There must be some kind of cycle in the graph. Everybody, like you might have a self loops if it is a multi-graph, but if it is a simple graph, there must be a cycle in the graph. They must be forming a cycle in the graph. And acyclic, there is no cycle in the graph. Just look at the previous graph, disconnected graph, but it is a cyclic graph. Why we say cyclic graph? Because somewhere cycle exists. Somewhere cycle exists. Everybody, in front of you there is an example cyclic graph. And in algorithms we study two types of graphs. At least one cycle, exactly. In the cyclic, at least one cycle exists. And weighted and unweighted, basically we don't use in theory, but when it comes to algorithms and applications, and weighted unweighted graphs are going to help you to find out the distance or to find out the cost, many things. If you go for applications like Amazon, Flipkart, or any other shopping applications, they have the connectivity of the graph. They might be talking about the cost, right? They might be having the connection between distributor to distributor, and they can map the cost. So when you sort out as per the low price to high price, and it looks the cost. If you are purchasing one item, this item might have the different cost from the different distributors. It's going to find out the minimum cost first based on your sorting order. Yeah. Yes, Raj, don't worry about. I'm going to take all of them. I'm just showing you types of graphs. Raj, don't worry about component. All the definitions will be discussed one by one. Yeah. I'm going to talk about everything, but I'm just showing you. We have mainly connected, disconnected is very important for us. Okay. Don't worry much about it. Connectivity, whole topic is about connected graphs and disconnected graphs. Okay, now I want to talk about quickly types of simple graphs. This is our syllabus. Yeah, here in the tree, again spanning tree, all of them are there. Yeah, Nishu. Now look at what are the simple graphs we are talking about. And remember, in these graphs, don't use the word which one? Parallel edges and self loops. Is that clear, everybody? You can use connected, you can use disconnected, but don't use the word self loop and parallel edges. And simple graphs, what we have? The graph may be connected. We will talk about every time what kind of graph we are looking at. Disconnected, and what else we have? No self loops and no parallel edges. Okay, and here we are going to use undirected, but some of the definitions might be used for directed. Here all of them I am using for directed, undirected. Everyone, all these definitions I am using for undirected. Remember the point, I am using for undirected. Okay, here we are using for undirected, which is very easy to understand. Undirected graphs. Okay, so let's start one by one. Path graph. Okay, how a path graph looks like. This is a path which has 0 edges. This has 1 edge, and this has 2 edges. This has 3 edges. Why we call a path graph? All the vertices are forming a path. Can you see that? Can you see that? This path graph must be a connected graph. In the disconnected graph, we don't have a path graph. This is the connected graph. All vertices are actually forming a path. And if you look at this path graph, if you see n, the number of vertices, suppose greater than or equal to 2, suppose if number of vertices greater than or equal to, you see something, a very interesting point. The first and last vertex, they have the degree 1. Remaining all vertices, they have a degree 2. Can you see that? any path graph you take, definitely two vertices will have the degree 1. Two vertices contain or having degree 1 and remaining all vertices having degree 2. So if you look at this, sum of the degrees is equal to twice the edges. You can prove from here. If you do not know this is a tree, actually it is comes under tree. But I am not talking about tree now, remember. Now sum of the degrees, if there are n vertices and e edges, look at how many edges are there in general. Degree 1 is happening twice, remaining 2 degrees happening how many times? n minus 2 times, which is equal twice the edges. Everyone, so what do you get here? If you look at that formula, which implies 2 into n minus 1 is going to come left side, right side 2 into edges. So 2 get cancelled, E is equal to n minus 1. So number of edges is nothing but n minus 1 in any path graph. Everybody? Of course, first time only we do that. Later on just assume, okay, it is a tree. It's one of the tree where there is no cycle and it is connected. And number of edges, yeah, it's about a path graph. Next, let's move to the cycle graph. Previously we have a P1, P2, P3, P4. Now we have C3. This is called as C3 and C4, C5. No Chetan, only discrete mathematics next 4 days में complete हो जाएगा. Just for Sankal batch, just for revision and practice of important concepts. Those people who are coming in between and going, please understand this is a Sankal batch where we have aimed to complete all the subjects in just 1 month. So we are almost in the completion, and this discrete mathematics will complete by 31st. Yeah. So what is this cycle graph? If you look at every vertex, is it 2 degree? Can you see that? Is it 2 degree? How did you get that? You can take a path graph. Let's say 4 vertices. Just connect the first and last vertex. Did you get the C4 or not? It's just a path graph, but additionally, you are going to add one edge to connect first and last vertex, so that forms a cycle, right? It's also called as closed path. Everybody, a path almost, but it is closed because first and last vertex is connected. And cyclic, cycle, both are different. What is difference? Every cycle graph is a cyclic, but cyclic graph need not be cycle. A cyclic graph is also connected. Agree? Impossible to draw a disconnected graph. Every cycle graph is connected, no doubt about it. And how many edges you will have? If I say cycle graph with n vertices, how many edges you will have? N minus 1 in the path graph, extra 1, so you will definitely have n edges. You want to prove it? 2 vertices, you will have n times, because every vertex is n degree only, 2 degree only. And it is just nothing but 2n is equal to e, so you get n is equal to e. Everybody, so number of edges is equal to number of vertices in a cycle graph. Yes, every node is having equal degree, north south, not only equal, it is a degree 2. Everyone? Just the difference between path graph and cycle graph, 1 edge. N vertices, n edges, there are n vertices, n minus 1 edges. Here, why we say cyclic graph? All vertices will participate in a single cycle. In one cycle, all vertices forms a cycle. That is the reason we say it is a cycle graph. Okay, now let's move. Let's move to the star graph. Of course, you can start with one vertex, two vertices, but no use of taking one vertex, two vertices, because it doesn't look like a star. But it's better to take from the four vertices, you will understand. Okay, this is a star graph with four vertices, 5, 6 and 7. Now if you look at the degrees, the outer vertices, they have degree 1, the center point, this is called as center, you have a degree 3. And look at other S4, everybody is degree 1, but center point has a degree 4. And S6, center point degree 5, but all the remaining 5 vertices, they have a degree 1. And S7, center point has a degree 6, remaining all are having degree 1. So what did you understand in the star graph? Is it a connected graph? Is it connected graph? Yes, it is a connected graph. Is it a cyclic graph? It has to be. No, yes, acyclic. All these points you can understand easily. My focus is on what is happening. Why we say star graph? Here, one vertex is adjacent to all other vertices. Yes or no? Only one vertex, only one, you can also write that word, only one vertex is adjacent to every other vertex. Only one, nobody else. Only one vertex is adjacent to all vertices. Remaining all vertices are non-adjacent except with this vertex. So now when you look at for Sn, if there are n vertices, what is the degree? Center point has the degree n minus 1 and remaining all vertices, that is n minus 1 times degree 1, you see, because 1 n minus 1 times, but one vertex has a degree n minus 1. Yes or no? The center point, its degree is n minus 1. And now this is equal to twice h. Let me write 2e. And this is n minus 1 plus n minus 1 is 2 n minus 1. So 2 gets cancelled, e is equal to n minus 1. So it is also a tree, because no cycle, right? Star graph also a tree, but did I give a tree definition? Not yet. Yes, path graph and star graph both are connected and both are acyclic and both are trees. Okay, let's move. Yeah, any doubt? Fine, wheel graph. What is wheel graph? Look at that. It's a combination of star graph and cycle graph. If you observe the center point, this looks like a star graph. And outer one, all other vertices are forming a cycle. So it's a combination of a star and cycle. Keep the star and connect all outer vertices to form a cycle. Everybody? So it's just like a star and a cycle. Now let's find out what is a degree sequence, something like that. It's a 3 degree, 3 degree, 3 degree. And what is the center? Center is having 3 degree. And now let's look at here, center is the 4 degree and remaining all are having 3 degree. So it looks like every wheel graph except one vertex, remaining all will have a 3 degree. That means n minus 1 vertices, no doubt. If you say wheel graph n, wn, then n minus 1 vertices have degree 3. One vertex, the degree, one vertex has degree. How much? For W4 3, W5 4 and W6 you have a 5 and W7 you will have a center point 6. And what do you understand? Degree n minus 1. Everybody agree? Clear this point? Yeah. Now answer it. How many, in general, how many edges for given n vertices? So n minus 1 vertices having degree 3. So 3 plus sum of the degrees n minus 1 times. Only one vertex has a degree n minus 1, which is equal twice the edges. So 3 into n minus 1, 3 plus n minus times, right? N minus 1 times plus n minus 1 is equal twice the edges, and 4 into n minus 1 is equal twice the edges. Then you got E is equal to n minus 1. This is one graph, not just a circle, Sharika. It's just not a circle, it is a whole wheel is a graph. Yes, but it looks like a combination of two concepts. It's just a one graph, don't assume two graphs. W4 is one graph, W5 is another graph. Every graph looks like it is interpretation of two combinations. You got it? In any wheel graph, how many number of edges? They might ask in the exam. W100, a wheel graph with 100 vertices. How many edges? How many edges? Then are you going to try? Don't do that. Don't do that. So you will have 2 into 99. That is a number of edges. Yeah. Let's move on. Very interesting graph, a regular graph. Previous all graphs, are they connected? Wheel graph, star graph, cycle graph, path, cycle and star, very easy. Wheel graph, just little bit complicated, but that is also easy. Now regular graph. Circle without arm. How can be a graph? In graph, you must represent edges, right? If you just draw a circle, who is edge, who is a vertex? Without a vertex, how can you draw an edge? Impossible in these concepts. Okay, that's a graph in aptitude. Right, circle is a graph in aptitude, graph in general mathematics, but not in discrete mathematics. You do have any vertex in this graph, guys? Do you have any vertex in this graph? How a circle can be a graph in graph theory? It is not a graph. Graph should have vertices and edges. Right? We don't draw a graph without a vertex. Clear? We must have the vertices. Edge is there or not, it is your choice. Okay? Of course, that is a graph, but not in this discrete mathematics. Okay. Here every graph is a combination of vertices and edges. Okay, ready? This regular graph, it can be connected or disconnected. First point, remember, in the exam you might be asked even disconnected graph. Previous 4 graphs, they are always connected, but this graph can be connected or disconnected. Everybody, but the point is every vertex must have the same degree. All vertices will have the same degree. That graph is called as regular graph. Look at, I have 4 vertices A, B, C, D, but it's a one graph. This is a regular graph with degree 0. Degree 0. We call it is a degree 0. Degree 0 even I can draw with 2 vertices. Everybody? And look at another one. I have another graph with, this is one graph. This is a one graph. This graph is also regular graph. But is it connected? No. But what is the degree? Degree of every vertex is 1. So degree 1 regular graph. Yes. Is that clear? There are some regular graphs which are disconnected. So don't do a mistake. Previous all simple graphs are connected doesn't mean that every simple graph is connected. Clear this point? Simple graph need not be connected. Okay, now let's look at this graph. Here degree 2 is there. A, B, C, you will have a degree 2. This is a 2 regular graph. 2 regular graph means every vertex has a degree 2. And 2 regular graphs are so many. Like you can see that there is another graph with 4 vertices. Here also degree 2 is another 2 regular graph. Yeah, regular graph with degree 0, degree 1, degree 2, degree 3 is so many. But every vertex in that graph must be same degree. Okay, let's look at many examples. Look at here. If you have one vertex, look at this, degree 0. Degree 0. This is a degree. We represent as R or sometimes D. Degree 0. And this side, vertices. Number of vertices. Clear? Look at degree 0, you can draw many graphs. Like with 1 vertex, with 2 vertices, with 3 vertices, with 4, with 5, degree 0 everywhere there. Right? If you want to draw a degree 1, you can draw with 2 vertices, with 4, with 6, you can draw so many. Right? In the exam they might ask, if the graph is regular graph and which has the degree 1, then how many number of vertices? Look at what I am trying to form. If graph is regular and every vertex has degree 1, then what can be n? What can be number of vertices? It must be even. Everybody, with odd number of vertices, degree 1 impossible. Degree 2 possible. And listen to me guys, Shubhajit Datta. And I don't understand the student mentality, that is which subject is easy, and that depends to you. I feel every subject is easy in the world if you spend the time, you study in proper way. Any subject you can make it easy. And remember the point, those subjects that you are feeling difficult but for other people they looks easy because they spent time, they understood the concepts, they worked hard, they practiced lot, then that day the subject will become easy. And no subject is easy in the world, and no subject is difficult in the world. And all things is because of your brain. Your brain is going to decide based on your approach, your hard work. If you don't do the hard work, everything looks difficult. Even GATE is difficult. Even whole life is difficult if you don't understand. So I beg everyone who are following on this channel, you are following my classes, please don't judge yourself. Any subject is easy, any subject is difficult. And spend the time to learn. You will understand by the time will it be easy or difficult for you. Nobody knows what you are going to do when you prepare. I'm only the person where I guide you all the time, but I don't know whether you follow me or whether you understand. I never know what you do until unless you ask the doubts. Yes. Fine. Understood the point? Yeah, if you are watching this video and you forgot to like, please do that. This is a degree 1, and when the degree 1 is there, the number of vertices must be even. Whether it's connected or disconnected doesn't matter. If every vertex degree is 2, the number of vertices doesn't matter. You can see that. Only I just told you for degree 1. Degree 2, anything is possible. You can see that cycle graph. Even I can make disconnected graph if I want it. Everyone? If I go for 6 vertices, here 6 vertices I didn't show you. If you have n is equal 6, I can make so many degree 2. So many. This is a degree 2. Every vertex is a degree 2. Can you see that? There is another graph. That is a disconnected graph. Look at this one. This is also degree 2, but 6 vertices are there. 2 cycles I made and 2 disconnected. Did you get degree 2 or not? Yes, these are 2 degree regular graphs. Clear this point? Yeah. Now let's find out. What could be the concept? Suppose, n vertices are there. Assume every vertex degree r. Assume every vertex degree is r. Now look at r, sum of the degrees, n times, right? N vertices. So is equal twice the edges. E edges you have, let's say. Then what do you get? N into r is equal to E. Then what is E is equal to? NR by 2. Clear this point? You can remember that regular graph always satisfies this equation. Number of edges you can calculate with the number of vertices multiply with degree by 2. Which will find you the number of edges. Okay, for any graph you can do that. Whether it is connected or disconnected doesn't matter. Okay, next very interesting graph, that is a complete graph. Complete graph. It's definitely connected. Not only just connected, it is a regular graph. Not only just regular graph, and every vertex has, if it is complete graph, let's say K is representation with n vertices, every vertex has n minus 1 degree. It means every vertex is adjacent. First time I am using the word adjacent. Adjacent means connected by an edge. Every vertex is adjacent to remaining all vertices. Means every 2 vertices are adjacent to each other. Every 2 vertices are adjacent to each other. Everyone? It means every 2 vertices are adjacent. It means there are so many definitions are there, but I am not writing, but you can understand. Suppose you have, yes, if you have, let's say, 4 vertices, what should be the degree of every vertex? 3 degree. If it is 3, then it must be connected to other 3. If this is also 3, 1 degree is over, it must be connected to other 2 also. And if you want to satisfy the 3 degree, this also should be connected to this one. Look at every vertex as a degree 3. It is a complete graph with 4 vertices, and it is a regular graph with a 3 degree. But anyhow, we don't care, because regular graph with 3 degrees, so many are there, not only this one. Okay, don't say every regular graph is a complete graph. What do you say? Complete graph is a regular graph. Complete graph is a regular graph. Every complete graph. But every regular need not be complete graph. Remember that point. Regular graph need not be complete graph. It may or may not. Even regular graph can be disconnected, but complete graph is always connected. अरे I have shown you connected graph यार, यही तो है connected example. Who is that? शिवा, यही तो है ना connected graph example. आपको रेगुलर ग्राफ की कनेक्टेड एग्जाम्पल है ये वाली, और इससे पहले बहुत सारे दिखाया यार. ये तो कनेक्टेड नहीं क्या? ये कनेक्टेड है, ये ग्राफ है डिस्कनेक्टेड है. अरे इतना सारे दिखाने के बाद क्या सोच रहे हैं आप? ये देखो, ये इस एग्जाम्पल में इतना सारे हैं एग्जाम्पल्स. ये कनेक्टेड है, ये भी कनेक्टेड है, ये भी कनेक्टेड है, यहाँ बहुत सारे दिख रहा है, बट ये तो है डिस्कनेक्टेड. ये सारे डिस्कनेक्टेड है. यहाँ इतना सारे एग्जाम्पल दिया कनेक्टेड डिस्कनेक्टेड वाले. देखो यार, एक सेल के अंदर एक कनेक्टेड है डिस्कनेक्टेड है. देखो बहुत सारे एग्जाम्पल है सामने यार. Okay, now if I ask how many edges, look at if it is kn, every vertex was n minus 1 degree. N minus 1, how many times? N times. What is the sum of the degrees is equal twice the edges. Then n into n minus 1 is equal to into e. So tell me how many edges you got. E is equal to n into n minus 1 by 2. So every complete graph, that means a graph with NC2 edges, E is equal to NC2 also you can write. So graph which has NC2 edges definitely is a complete graph, but that should be a connected. Remember, in disconnected graph, of course, I don't know. Of course, disconnected graph not possible anyhow. If a simple graphs, in a simple graph, if you have NC2 edges, that must be complete graph. Jayesh, no need to be. Bipartite graph, no need to be. Bipartite graph, no need to be connected. बीच में क्यों आया bipartite graph? Okay, look at the complete graphs. This is the K2, this is the K3, and it's given already K4 and K5. If you look at K2, you have degree 1, degree 1. K3, every vertex is degree 2. And K4, degree 3. And K5, degree 4. Every vertex as, every graph, every complete graph has degree n minus 1 when you have n vertices. Clear? And Kn has n vertices, that is our notation, and nc2 edges, means n into n minus 1 by 2 edges. Okay. Now bipartite graph. What is bipartite graph? A bipartite graph has vertices. If we can divide set of vertices into two subsets, two disjoint subsets. Remember, two disjoint non-empty subsets. And in each set and vertices of each set are non-adjacent. Vertices of each set, or you can say vertices which are present in each set are non-adjacent. Every two vertices. then bipartite graph will appear. Basically, we may not understand bipartite graph by looking at a graph, but you need to verify, can I divide the given set of vertices into two disjoint non-empty subsets, and vertices in every set, they are non-adjacent. Example, look at it. Suppose I have a graph like this. How many vertices you have? Four vertices. Can I divide this into two sets? Like A, C I can keep into one set. This is a one set, and B, D is other set. And look at that. Are they non-adjacent AC? Yes. B, D non-adjacent. These are non-adjacent vertices. Here also non-adjacent. And I basically divide into two sets, V1 and V2. Here actually V is given. Here V is given as A, B, C, D. But I am trying to understand V1 and V2, two different subsets, and disjoint means intersection must be empty. But when you do the union, you must get the same. And A you connected to B, C you connected D. Now look at what is bipartite graph. Bipartite graph will not be mentioned sometimes. They might ask which of the given graph is bipartite. It might be connected or disconnected. We don't care. It could be connected or disconnected. If they say connected, just follow the connected. Only definition is the graph. In the graph, the set of vertices can be partitioned into two subsets. Everyone, now let's practice which are bipartite graphs. Okay, before going to complete, let me explain some of the bipartite graphs. Okay, look at this. A, B. Is this bipartite graph? First example. Is this bipartite graph? Look at that. I can divide this A separate, B separate. Yes. Right. I am able to divide into two sets. It is bipartite graph. Second, A, B, C. Can you divide into two sets? There are so many possible ways to draw, but I am just showing it. A comma C I can put into one set, B I can put into other set, and A connected to B, C connected to B. Yes, A and C are non-adjacent, B is alone. It is bipartite graph. It is bipartite graph. You can represent this bipartite graph is 1 comma 1. This is like 1 comma 2, or you can say 2 comma 1. Everyone understand the graph as two set of vertices. Given graph is different, we are doing a different because we want to understand given graph is bipartite or not. Right? These are bipartite graphs. Right? You need to do homework to practice these bipartite graphs because they are not visible directly. Is it bipartite graph? These three vertices is not bipartite graph. Why? Because it's not possible. It's not possible to make the two sets. If you want to make, you can make a tripartite, but we don't have tripartite graph in general. If anybody makes that definition, that's different. We have to divide given set of vertices into only two subsets. A, B, C. Is it possible to make the two subsets? Is it possible to make the two subsets where one set has all the vertices are non-adjacent? No. That is the reason. But these two are bipartite graphs. Because it's not visible, you need to practice. Yeah. All edges are non-adjacent. All edges are adjacent. Yes. And look at the fourth one. A, B, C, D. Is it bipartite? Try it quick. Is it bipartite? Yes. How did you understand it is bipartite? How did you understand? Because in mind, I have applied the definition. I am able to make two independent sets, like A I can keep with the C. We don't connect AC, guys, just one side we keep, that's all. I'm able to make into two sets. A is only connected to B and A is connected to D. That means vertices of one set only adjacent to the other set. Remember that. And C is connected to B and C is connected to D. So this is G2 comma 2. There are so many graphs in the world G2 comma 2. Remember, don't assume this is only one graph. G2 comma 2, even I can draw like this. A, B, C, D. This is also G2 comma 2. This is also G2 comma 2. There are so many graphs in the world G2 comma 2. And this one G1 comma 4. Yes or no? C you keep one side. All A, B, D, E, that all remaining vertices keep other side. Then C is only connected to them. And A, B, D, E are non-adjacent. Yes. So 4 is bipartite, 5 is also bipartite graph. Okay, this is already written. Understood what is a bipartite? It can be connected or disconnected. Yes. Okay. You can understand only when you understand the first page. If we can divide the given set of vertices into two partitions, then what is each subset here? This is the one subset. This is other subset. What are you looking at by dividing into two subsets? In each subset, the vertices of the one subset should be non-adjacent. Can you draw such a graph? Then only it is a bipartite. Yeah, it's not over yet. Let's begin complete bipartite graph. This complete bipartite graph is a connected graph. This is the connected graph. Everybody, this is the connected graph. Then what is this complete bipartite graph? If you are able to make the two sets, let's say V1 and V2. If you are able to make V1 comma V2, two subsets. This is a subset 1 and this other subset. And vertices, every vertex of V1, every vertex of V1 is adjacent to all vertices of V2. Then we say it is a complete bipartite graph. Everybody, so I'm saying again, if there is a graph with vertices V comma E, the same graph you are able to make two sets V1 comma V2 and edges is same. And here the vertices of V1 are only adjacent to vertices of V2. Similarly, and vertices of V2 are only adjacent to vertices of V1. It means the all vertices in V1 are independent. This is independent set. It means independent definition is all vertices in that set are non-adjacent. This is also another independent set. Then we say this is bipartite graph. Whether it is complete or not, that is a different definition. If somebody said, sir, I didn't understand bipartite graph, I am explaining. Now, what is the complete bipartite graph? If you have, let's say, x1, x2, x3 and y1, y2, y3, y4, and I'm assuming this is a v1 and v2. These are two sets are there. Two sets. v1 is equal to x1, x2, x3 and they are non-adjacent. v2 is nothing but there are four vertices. Then what is this complete graph? Either you can say k3 comma 4 or you can say k4 comma 3. This is only one graph which is a complete bipartite graph for 3 comma 4. And what is the definition? This x1 is adjacent to all the vertices of other subset. Now similarly, you have x2 is adjacent to all the vertices of other set, and similarly x3 is adjacent to all other vertices. Indirectly, y1 is adjacent to all the vertices in v1. Can you see that? y1 is adjacent to all the vertices in v1. Similarly, y2, y3, y4. Did I miss anything? So you have to cover it. I missed it. Okay. Everyone, even x2 also. Sometimes I miss it. Yeah. 4 should be there, right? Fine. And all of them, you can see, all of them, every vertex is adjacent to all vertices in other set. So how many edges? Now here I can find something. Suppose I have, and not easy, I'm just trying to finish up very quickly. K, M, comma, N. If this is a complete bipartite graph, how many edges are there? How many edges are there? How many edges, guys? You can look at that. Sum of the degrees is twice the edges, right? Right. If you assume there are m vertices in left side, let me say x1, x2, I have m vertices, y1, y2, I have n vertices. Then x1 degree is how much? Degree n. Here degree n, degree n. Here degree m, degree m, degree m. So here what are you going to do? You are going to do n plus n plus n m times, because that many degrees are there, plus, and m plus n times is equal twice the edges. So this one will give you mn and this one will give you mn. So mn plus mn is equal to twice the edges. So 2mn is equal to e. So mn is equal to e. Yeah, we should, hello. Everybody clear this point? Yeah, that's even length cycles only possible because you need to go other side, you need to come back. So only even length cycles are possible. Note, if you want to look at the cycle length, only even length cycles are exist here. That's true. Because to form a cycle, you cannot use odd number of vertices. Only even length cycles are there. Sometimes not there, but complete graph always possible. Only even length cycles are possible. Clear? If you look at the so many graphs are there here, K23, this is a K23 or K32, you can say anything, both are same. This is a K33, you have 3 vertices and they are non-adjacent, other 3 vertices are non-adjacent, and you know the adjacency, every vertex in one subset is adjacent to all other vertices in other subset. This is a K35 or K53. A number of edges you can count later. Okay. Great, Vivek Sai Yadav. I am also from Hyderabad. Okay. Let's focus on tree. And you know, tree is connected graph. Connected graph, disconnected graph never be a tree. And no cycle should be there in this graph. Acyclic graph you can say. And what else? What else? Is there any? No cycle is there. And connected graph. Is that enough? Together when I mix, it is minimally connected graph. any graph which is hierarchy. But here we don't use a rooted tree in the normal definition. Everybody understood what is a tree? Tree need not be rooted, remember that. Okay, now example, if you have example this one, path graph, you know, right? Path graph with 3 vertices. Is it tree or not? It is a tree. Now here there is no root here, but tree definition is not that root always there. That was the rooted tree. When you are applying for particular data structure or particular problem you are solving using data structure algorithm, you might need binary tree, binary tree, AVL tree, right? Ternary tree or general trees. Then you need it. And even you have a star graph. It is connected all. It is a connected graph. It is a connected graph. Directed or undirected is your choice, guys. But I am only explaining for undirected now. It is also a tree. That means every path graph is a tree. But tree need not be path graph. And every star graph is also tree. But tree need not be star graph. Yes or no? But tree need not be path graph and star graph. Tree need not be star or path. Okay. Now what is the tree property? What is the tree property? It depends on what structure you have. Tree always will have n-1 edges. So any connected graph which has n-1 edges, it must be a tree. Any connected graph with n-1 edges is always a tree. Any connected graph with n-1 edges is called as minimally connected. Clear this point? Okay. Now a forest. What is forest? Basically it is trees only, but it is a disconnected graph basically. Mostly we use for the disconnected. Of course, if you use for connected, a single tree is a forest. It is a trivial forest. Remember that. So I am using for disconnected. But when you use for the connected, it's not a forest, it's just a one tree. If you use for connected graph, it is just a tree. But disconnected graph is just disjoint trees. So you use the word tree if it is a connected graph. Use the forest if it is a disjoint trees. Just like a jungle, yes. Example. This is one graph. This is one graph. Look at that. How many trees are there? This is a subtree. Here 1, 2. There are 3 subtrees are there. But the graph is not a tree. But graph is called as a forest. This graph is a forest. Why? Because there are 3 disjointed trees are there. You can say subgraphs. Every component is, you can say that word called as every component is a tree. Every component is basically maximally connected subgraph. Okay, that word I will use later on, guys. Every component is a tree. Here there are 3 components. 3 components in this disconnected graph, where each component is a tree. Then we say forest. अगर एक भी ऐसे ट्री नहीं है उसको फॉरेस्ट नहीं बोलेंगे हम. We don't say forest. Yeah, you can use DEVALIVE as a referral code, Yadav. You can get a plus subscription. Yes. Okay, and today, I'm not able to cover because of the patients, because of health conditions. I'm going to use this connectivity on tomorrow. But look at how many topics we are going to learn. Tomorrow, I'm going to start directly with the component word. And then I said the connected directed graphs, so many definitions: strongly, unilateral, and weakly connected. Undirected, we don't have this many definitions, but connected we have. I'm going to help you there. And then strongly connected component, then cut vertex, then bridge, then cut set, and vertex connectivity, edge connectivity. Then tomorrow we'll practice, if you delete a vertex, how many components are there. So tomorrow we are going to practice here, everyone. So, and I know I cannot cover this connectivity within few minutes, so let me leave this point to you right now. So tomorrow I'll come up with this connectivity along with other topics if possible. So today I had just, I helped you to understand the types of graphs. Even I didn't help you many types, just whatever is important for gate. Types of graphs I've helped. Yeah. Tomorrow we will understand clearly how connected and disconnected will help us in the connectivity. Right? So thank you so much for joining today's session. In the next class, we start with the connectivity. In case you need a subscription, use DEVALIVE referral code. And batch is already started and more batches are going to come. Whenever the new batch is going to be announced, we will promote here and you can join as per your interest. But one batch is already started by RBR sir and Computer Networks is going on right now. This is the first batch for GATE 2022. And in case if you want to take the subscription, we have two things, plus iconic. And plus you have much benefits. As I said, that you have structured courses, you have batch wise courses, and iconic, all the benefits are there. Additionally, personal coach, separate study material and study planners and booster sessions and many more. And if you want to know the prices, you can look at that. Every class on YouTube, we promote this. In case you forgot to see the payment, you can see that here. And this is going to help you to while paying the amount. So for 2 years, if you are going to take the subscription in case, you will see 39,600 after applying my referral code DEVALIVE. If you don't apply, you will see the more price. Similarly, iconic also you can see the total price after applying the referral code. So choose according to your requirement. This is my profile where you want to, if you want to access my classes. And these days I have taken few classes on special. I'm going to start soon from tomorrow mostly. I'll announce our entire schedule that I'm going to take on Unacademy, so you can attend according to that. And this is our Telegram channel. Please subscribe to this in case if you want to download the materials from us. Yeah. Next class, Deepak, chromatic number, edge chromatic number. Chromatic number used for the vertices and what regions, and you want edge, I will teach. But do you really need, what kind of application you need an edge? Yeah. So we have so many YouTube channels where they are absolutely free and they were operated by the top faculty, top educators of Unacademy. So please share with your friends if anybody is studying in electrical, electronics, mechanical, civil and including CS. Yeah, thank you so much for joining today, and don't forget to use my referral code in case you wanted to take the subscription or you wanted to come to the Unacademy. Then share with your friends if you want. If you feel that you need to share with your friends, and subscribe. And thank you so much for joining today's session. I'll be joining tomorrow. Tomorrow class is 8:45 AM. Okay, tomorrow timing will be same. Only today because of health conditions I was not come on time, but tomorrow I'll come on time. Try to.